Here we have another problem, predicting products. And here we're starting from benzene and have these reaction sequence. Again, we need to start doing each, we're going to draw the product of each of the steps. So from benzene, step 1 here is a nitration. So I have nitric acid, sulfuric acid. What this does is you're going to be installing a nitro group here. Second, we have another reaction. Next is to determine what is the nature of that. So the nitro group is deactivating and is meta-directing. So it will direct in this meta position, which are equivalent. So you're going to install a bromine. So the second step is a bromination. So bromine, and you're using iron tribromide, and because it's nitrous meta directing, so you're going to put the bromine meta to the nitro group. That. The next step is a reduction of the nitro group. So here we have zinc and hydrochloric acid, and you will have the following. That's the amino. So the fourth step is what? Now we have two groups. But I'm going to do a couple of things. So I'm going to do, say that I do here treatment with fuming, sulfuric, and also here. So what is going to happen? Let's see if the order in which I do things changes the product. So here, again, fuming, sulfuric acid. In the case that we're following the sequence, we are doing fuming sulfuric acid. Now we need to analyze the nature of these two groups. So activating, orthopara directing, deactivating, also orthopara directing. When you have two groups like that, activating, deactivating, the activating group is the one that is going to be determining where the substituent goes. You're installing a sulfonic acid group. In between these two, it's not going to go. Remember, there's a lot of steric hindrance. So not going there. And so orthopara to the amino group, you have this too. And again, the activator is going to determine where is the substitution. This is the activator. So you're between this two group, this is determining where is the substituent going. So you have two possible products. You have, here's your bromine, and you will have the sulfonic acid here, and you will have it also next to the amino. Oh, note that position with, because steric hindrance, right? So the other position, so you have it, what did I do here? The bromine, yes, so para to that, the ortho here. So sulfonic acid here. And I'm going to have to erase these arrow because I said I'm going to put it pointing somewhere else. What if I, instead of doing the sulfonation at this step, I decide to do it over here? What would happen if I don't reduce the nitro to an amino group? So analyzing this, I have deactivating group, but bromine is weaker deactivator than this is. So when you have two deactivating groups, the weaker is going to determine where the substitution goes. So this is, let's write it down, weaker deactivating, and this is strong deactivating. So between these two, bromine is going to determine where the substitution is going to happen, and it's going to be ortho or para to the bromine, this para. So you're looking at the same positions, but you're going to be having a nitro group. So at this stage, it's like I don't have much room, but let's erase this. We're erasing the whole list of reactions. So if I did fuming sulfuric acid here, fuming H2SO4, I'm going to be installing the sulfonic acid in those positions, but now I have a nitro group. So it has directed by coincidence to the same place, so SO3H, but because the bromine is the group that is determining where is the substitution. So again, when you have multiple substituents, pay attention to the type of substituents you have. When you have here activating, deactivating group is the one that rules, determining where the substituent is going to go. So is ortho, para, the activating group. And in this substrate, we had two deactivating groups. So the next substitution is going to be ruled, say, by the weakest of the two deactivating groups, so the bromine. And this is why we get that. So whenever you have a problem like that, a sequence of reaction, draw the products at each step and do the analysis by knowing what each reagent does and determining what is each substituent activating, deactivating, and where is it directing.